Restoring SQL Server. In this nugget, we're going to start by talking about some of the different recovery scenarios in SQL Server, including a complete database recovery, file recovery, and page recovery. We'll actually walk through a complete database recovery to see what data we lose and how much we can keep. Then we're going to spend a little bit of time talking about various concerns and issues around recovery, including marked transaction, encryption, and orphaned users. And we'll spend just a couple of minutes talking about the importance of practicing your recovery plan and some techniques that you can use to safely practice your recovery plan without upsetting your production server. Let's start by looking at some of the different recovery models you have with a database. The first is pretty simple, and it's called a database restore. That's a complete restore of the entire database. Now, this is supported for databases that are in the simple recovery model as well as the full or bulk logged recovery models. And this is kind of the basic strategy. This is the one we'll spend the most time on because it's the one you'll probably wind up using the most. Now, you can also do a single file from the database. So for databases that are spread across multiple files, a file recovery is possible. Now, this also works for simple, full, or bulk logged recovery models, but there's a trick. You have to have at least one read-only file group in the database. Now, as a benefit, this has the opportunity to do online restores, meaning that as you're restoring a particular file, the database itself can remain online. That feature is only available in enterprise editions of SQL Server. Now, the next level down is, rather than restoring an entire file, is to just restore one or more pages from the database. Now, this is only available in full or bulk logged, not simple recovery modes. And again, to keep the database online, which is a potential, you do have to have one of the enterprise editions. Now, we're not going to spend a ton of time on page, file, but we are going to spend a lot of time on databases. We will walk through these other two. However, you should spend a little bit of time in the SQL Server books online. There's a recovery topic or a help topic called Backing Up and Restoring Databases in SQL Server, and it's got a really helpful table of all the restore scenarios, such as a complete database restore, and it explains how they work under the simple or the full and bulk logged recovery models, and provides links to actually performing those tasks. So you've got a complete database restore, file restore, page restore, and then what they call a piecemeal restore, which is kind of a combination of those. And it lets you know what works. So you see that a page restore does not work under the simple recovery model. This is a good table to review because it'll really kind of help put all of your options together for you in one place. So let's sort of start with the strategy of the full database recovery model. It's the easiest one to understand, and its process sort of drives how the other models work as well. So the basic idea is your database is crashed. What do you do first? Well, first you restore the most recent full backup. Now, that's not going to have all of your data, so if you have any differential backups, you're going to restore the most recent differential backup next. Now, this is kind of where the SQL Server recovery model comes into play. When you restore a file into a database, by default, SQL Server will immediately start the recovery process, which means it tries to go find any missing transactions or anything else. So after you restore this full backup, you're going to tell SQL Server, as part of that backup, no recovery. Now, it's one of the options you have during a restore, and that tells SQL Server, I want you to restore this file, but I'm not done yet. There's going to be more coming, so don't go crazy on me. Just wait for the end. So then you're going to do the differential backup and also specify no recovery. Then you're going to restore your transaction logs. And this is kind of a tricky bit here. You need to restore every single transaction log that has occurred since the last differential backup, and you need to restore these in order and specify no recovery until you do the last one. When you restore the last transaction log backup, you do not specify no recovery, and that tells SQL Server, okay, here's the full database, here's the differential, here's all the logs, go to work. Start recovering all my data, process all of those transaction logs, get everything up to date. So that's when the recovery process actually starts. Now, one of the tricky bits can be actually making sure that you get all the right transaction logs restored and that you get them restored in order. Now, these logs actually have a sequence number internal to them. There is a way to bring a log back, just the headers of the backup, so you can see what the sequence number is so that you can make sure you're restoring them in order. Now, we got to say a couple of things here. First of all, a well-planned backup strategy and good backup documentation will save your life. If you can look at your backups and know, okay, this is the full backup, this is transaction log backup number 1, number 2, number 3, number 4. If you can keep track of that, your life is going to be so much easier. I can't even start. However, let's look at what happens if you don't have that information, how you can go extract it from SQL Server. Probably the best place to start is in SQL Server Books Online, because the commands and the sequences you're going to have to run are rather particular. This is not something you're going to memorize. This is something that you are absolutely going to look up when you have to. So look up restore sequences in the help, and there's a section called About Restore Sequences. That's where you'll start. And this kind of talks about log sequence numbers and restore planning. It tells you how to determine the time interval that's contained within a particular log backup and determine whether or not there are more log backups to go. For example, if you know you've got a log, and again, by the way, this only applies to the full or bulk log recovery models, because in the simple recovery model, you don't have transaction logs at all. So you don't have to worry about any of this. In the simple recovery model, it's just your latest full database backup and the most recent differential, and that's it. So what you're going to do is take a look from the MSDB backup set table. That's a table in one of SQL Server's system databases, MSDB, and that will really list all the backups that have been made and the file that they went to. So the interval contained in the first backup log in the backup log chain extends from the backup start date to the backup start date of the next backup. So there's no backup end date. It just keeps track of the start date for each one. And it really does a great job of walking through. This help topic is a must read, and it gets really, really advanced. For example, read up on log sequence numbers, and it'll explain that every transaction log has a unique log sequence number, and that to get that information out, you're going to have to use something like the restore header only command. That will allow you to restore just the header of a backup so that you can see what's in there. And it also explains how to use some of the system management views that are available and other techniques for finding this information. Again, I want to stress that this is suboptimal. You need to know that the capability is there, but this is not the ideal way to proceed. Hopefully you've got good backup documentation so you know what backups go in what order ahead of time. If you have to get into these commands, then it kind of represents a failure of your management processes. And I want you to understand that this capability is here. You can go and see it, but I want you to come in and read the help, because it's an extremely detailed set of commands. For example, if we look at restore header only, you can see that this is a complicated command with a lot of options, and there's the exact set you're going to use depends on the exact scenario that you're into. Ideally, you don't have to come in here at all, but you do need to know that the capability exists. Now, there's one last planning thing that we need to be aware of before we start talking about how to actually do a restore, and that's something called a recovery path or a recovery fork. Let's say I restore a full database backup, and I don't have any differential backups, so from there I restore log number 1, log number 2, and log number 3. Okay, so that gets me back up and running. We're going to draw a little line there to let me know that that's all I had to do. So I've recovered all my data, everything's great, everything's working according to plan. Now I go back to using the database. Log number 4 backup is generated, so I create that backup, and then I keep using it, and I create a log backup 5. But for some reason, I've lost this guy. Well, this creates something called a recovery path or recovery fork. If I lose the database again here, I have to go all the way back to the beginning and restore all of these things, and then the next thing SQL is going to want to see is log 4, and let's say there's a problem with that. So now I've created this very complex scenario that SQL Server has to deal with. The Books Online actually has a really good illustration of what this looks like. Again, if you look for restore sequences and then click on the recovery paths topic, it kind of starts by showing you here's the ideal situation. You restore your full backup first, and then backup log, backup log, backup log, and all is well. And now the best practice is to immediately take a full backup of the database. That creates a brand new point in time. If you do that, nothing from then on will be any more complicated than the original restore. But what can happen if you don't is, let's say we've got this database backup 1, our next log, and our next log, but the database is then recovered here without restoring the T4 backup. So we've got another transaction log backup out there that we didn't restore for some reason. Now, there might be a good reason to not restore that. Maybe transaction log 4, that's represented by T4 in this diagram, maybe that had some data we deliberately did not want to recover. Maybe we didn't lose the database file. Maybe we're doing this file restore because a bunch of operations were done that we want to roll back. And those operations are in transaction log 4. So if we restore the database backup, restore the transaction log 2, restore transaction log 3, and then we create a database backup, we have established a new recovery path. So now recovery path 1 would be to go back, restore T1, T2, T3, and then T4 if we wanted to. Recovery path 2 is to go to this new database backup and restore the next transaction log T5 after that. So you see how we've kind of created a branching here. Ideally, we only keep this new database backup and we discard everything that came before that if this is the point in time where we want to be. So where things can get really complicated is when you've got multiples of these paths. So again, they really are clear here. The best, and here's the problem we have. Now if we didn't make that full backup, we'd have to go back to T1, T2, T3. Remember, we didn't want T4, so now we have to remember to go to T5, T6, T7, T8, T9, and so forth. It just gets more complicated. So the best practice, which is detailed right here, to avoid creating a recovery path that has multiple recovery forks, perform a complete set of data backups as soon as possible after completing your database recovery. This makes sure that all the backups are taken on a single recovery branch. So keep that in mind. After you successfully restore a database and you're thinking to yourself, okay, this is the point in time where I'm happy with my database, I've wiped the sweat off my brow, I'm relieved that we're back here, get a full backup of that point. That creates a brand new recovery path, not multiple forks along the same path. So something to keep in mind and a very important best practice. All right, let's get SQL's Management Studio up and we will start a restore operation. Now one place you can start is to go to the database that you plan to do a restore on, right-click it, go to Reports, and then there's a set of standard reports. And we can look at the backup operations, backup and restore events. So this is going to tell us the average time taken for backup operations. It's going to tell us when the last successful backup operations were, any errors that occurred, and any successful restore operations. And we're going to see that there were no successful backup operations performed. If we need to restore this database, that's not good news for us. So what I'm going to do now is pause the recording and I'm going to take a full backup, pretty much just like I discussed in the previous nugget on backing up SQL Server, and then we're going to come back and do some restore operations. Okay, here's where we are. I put 3 rows into this database table and then made a full database backup. I added rows 4 and 5 to the table and made a differential backup, and then I added rows 6 and 7 to the table and made a transaction log backup. Then I added an 8th row, and I have not done any backups of that. All of these backups, the full, the differential, and the log, are in a single backup file or backup device called full.back that's sitting out on disk. So what I'm going to simulate now is a failure situation where I lose the database, and I'm going to predict that I'll be able to restore rows 1, 2, 3, 4, 5, 6, and 7, but then I'm going to lose row 8. So let's actually go into the database and see that that's there. We're going to edit the top 200 rows. You can see that I've got 8 rows in here, and I'm predicting that I'm going to lose this last one when I experience my complete failure. Now, In fact, it's kind of unusual for just total disk corruption to be the reason you do a restore. More often I find it's because someone's done something bad with the data. So let's go in and edit the top 200 rows and select them all and hit delete. Oh my goodness. Now keep in mind what's happened here. The last row, row 8, is in the current live transaction log that hasn't been backed up. That delete operation is also in the current transaction log, which hasn't been backed up. I don't want to recover that. So let's close this. The database is now empty because it's only got that one table, and I deleted everything out of that table. I might even come in here and just delete the table, but we're simulating someone doing something bad with the data. Now let me show you one option you've got. I'm going to go into the database because the database is still live. I haven't lost the disk or anything like that. I'm going to go to Tasks and look at the backup here. I could at this point choose to do another transaction log backup, put it in the same file, and say all I'm really after here is I want to back up the end of the transaction log and leave the database in a restoring state. Now, because I don't know everything that's in that transaction log, I might not want to do that, but it's an option that you have. And I'm going to show you why you might do that. I'm not going to do it here, but when we go in to do the restore, tasks restore the entire database, you have an option to restore the database to the most recent possible transactions, which will be everything that's included in the database file backup, or you can restore it to a specific point in time. So what you might want to do is grab the most recent transaction log into a backup so that you have the option to restore some of the transactions. If you're able to identify a point in time, let's say, oh man, we know that Sally at 4 o'clock in the afternoon deleted all the rows. We want to restore up to 3:59 in the afternoon so that we miss all that delete action she did. I'm not going to do that though. So what we're going to do is specify our backup device. I'm going to go to my file, which is on disk, and see backups full.back, and tell it OK. These are the database backups that live in that backup device. I want to grab the full, the differential, and the most recent transaction log backup. So let's hit OK and let the restoration begin. Now normally a restoration is going to take a while. This is a fairly small database and the backup logs don't have a lot in them, so it shouldn't take a long time. In fact, there's one specific problem you need to be aware of, and we may actually see that problem crop up here. Notice that the execution is staying on 0%, but it seems to be trying awfully hard to do something. It turns out it was trying to get exclusive access to the database. See, there's still users attached to the database. They're still doing stuff. SQL Server can't very well start a full restore if people are already trying to use the database. So what do we do about that? Well, if we're just bopping around in SQL Server Management Studio, we might see an option to take the database offline. Now that leaves it attached to SQL Server, but it unconnects everybody who's using the database and makes the database unavailable for future connections. So let's see what happens. Okay, successful. We were able to take the database offline. Now let's go to tasks and, oh wait, we can't restore a database if it's offline. Well, that's okay. By taking it offline, we've disconnected everybody. Let's just bring it online. And that will hopefully get everyone disconnected from it. So now we can come in, specify our file device, select our backups, and we can continue. Now before we continue, I want to talk about some of the options you've got. There's really 3 options for the database's recovery state. The first is to leave the database ready to use by rolling back uncommitted transactions, and additional transaction logs cannot be restored. You're going to choose this option if that database file has got all of the backups you need. If this is the complete list of everything you need to restore, then you pick the first option. If, on the other hand, this isn't the complete list, if after restoring these, you then need to go to another database backup file to get some more transaction logs, you need to select the second option. Leave the database non-operational and do not roll back uncommitted transactions. Additional transaction logs can then be restored. Your third option is if you're really not sure what you want to do. What that says is leave the database in read-only mode. Undo uncommitted transactions, but save that information in a standby file so that the effects of your recovery operation can be reversed. What that lets you do is try to do a recovery, stop, look at the data in the database, decide if that's what you want. If it's not, you can undo the recovery operation and try something else. Maybe start with a different full database backup. Once you get to the point where you're happy, you manually go in and take the database out of read-only mode just by modifying the database's properties. So we are going to go ahead and hit OK and start this restore process. And SQL Server doesn't seem to be happy with us. Here's why. We've still got some transaction log data sitting out there. Remember, that last transaction log we've got, the active transaction log, has got our 8th database row, and it's got all of the deletions, all those rows being deleted. SQL Server doesn't want to assume that we don't want that information. So it's telling us that the tail for the log hasn't been backed up, and that's a problem. So we have an option. We could either go back up the tail of the log, and if we don't want what's in there, we don't have to restore it. Or we can use backup log with no recovery to back up that log if it contains work we don't want to use. Or we could say, instead of that, we're going to do the restore using the with replace or with stop at clauses. Here's what that looks like. In the options, well, the with stop at would be to, instead of restoring to the most recent possible time, we would restore to the time just before that outstanding transaction log started. Or we could say overwrite the existing database. Let's try that. And now the restore was completed successfully. So let's go into the database, let's look at that table, edit the top 200 rows, and there we go, runs rows 1 through 7. We have at this point lost that outstanding transaction log. It had row 8 and it had all the deletions in it. We chose to give that data up. It's possible we could have backed that up and then looked inside of it to see what point in times it had and tried restoring to various points in time until we got just the data we want, but not that last deletion transaction that went in. So you've got a lot of flexibility to play around with these different restore modes and restore operations. But this is the basic full database restore. Now those other recovery models, those other restore scenarios are a little bit more rare, but SQL Server books online, as always, will help you find them. If you just look for restore scenarios, implementing restore scenarios in the help, you'll see that it shows you how to do a full restore for full and simple recovery model, an online restore, a single file restore, both for the simple and full recovery model, performing page restores, which again only works in the full recovery model, recovering a database without restoring the data, and so forth. So just as an example, let's look at the performing page restores to see what's involved there. And the goal of a page restore is when you know your database is okay, but you've got one or more damaged pages, which basically means a portion of the database file itself has gotten corrupted somehow. You don't want to restore the entire database. Typically, pages that are candidates for a restore have been marked as suspect because of some error. Those are identified in the suspect pages table in the MSDB database. Now, not all page errors require a restore. And this help topic really runs through some of the details. And I have to stress, this is an extremely advanced level restore. Basically, what you need to know on the surface is that if a page has been marked as suspect in the suspect pages table of the MSDB database, then that's when you would do a page restore. You can restore multiple database pages, and the log file backups are then applied to all database files that contain a page which is being recovered. This is going to run through several different scenarios, including an offline page restore and an online page restore. Some of the limitations: so page restores cannot be used to recover the transaction log, only the database pages. It's also going to walk you through some of the requirements that must exist. You have to be in the full or bulk logged recovery models. Pages in a read-only file group can't be restored. The restore sequence must start with a full file or file group backup to bring the missing data back into the situation. Basically, what SQL Server is going to do is take your existing database, take your full file or file group backup and then just go into the backup and grab the pages that are corrupted and copy them over. It's really almost like if you tried to restore all the files on a disk, but you only wanted to restore a few of them that were missing. You just go to the backup and grab the ones that were messed up rather than grabbing the whole set. So it really walks you through the entire process, including the syntax, everything else, the complete procedure. Good to familiarize yourself with some of the restrictions, but again, this is a very advanced scenario, which is why we're not covering it in more detail. Now, the other option is to do a file restore rather than a database, and this is a little bit less granular than a particular page. Again, it's worth your time to walk through some of the scenarios. When can you do offline? When can you do online? But again, this is a fairly advanced topic. It's not something that most database administrators need to do on anything even approaching a regular basis. You need to be aware that the capability is here, and you can walk yourself through some of the restrictions and how to do it. But if you actually need to do this, you are definitely going to turn to the help file to see the procedure, and that's why it's most important for you to know where this is in the help file. Now let's talk about another advanced scenario that you need to be aware of. Let's say I have two different databases, database A and database B. And these guys contain data that is related to one another. In other words, I've got client applications out there that are making changes to both databases simultaneously. It's kind of a difficult scenario, but it's one you have to be able to deal with. So here's kind of the sequence of events. I'm doing regular backups of my databases. So over here I've got my full database backup 1. Maybe I've got a differential database backup, which is file 2. And then I've got some log backups, log 3 and log 4. Database B is being dealt with differently. It's being, it's its own entity. So its database backup 1 might be occurring a little later in time. Maybe it's 3 hours later than database A's backup 1. Its differential is maybe a couple hours after database A's differential. And then maybe all I've got for it is one log backup. I haven't done any log backups recently, so that log is accumulating everything. Now, when we restore this, in order for our data to be consistent, we need to somehow figure out, okay, we need to restore to this point in time, and we need to know somehow that that's right there in this log file. Well, the way you do that is called a marked transaction. This is not something that you as the DBA can do. This is something that the client application, which is writing to these databases, needs to be able to do. So it's called a marked transaction. There's some SQL Server syntax that handles this. For example, here you see a sequence of T-SQL code, and this is saying begin a transaction called list price update with mark. And this is a description of what the mark is. This places a mark in the transaction logs of both databases so that we know at a point in time where this occurred. We're saying that at this point the two databases are consistent with one another. So you begin the transaction and then you do whatever is going to occur within the transaction. You update the two different databases and then you commit the transaction list price update. Once that happens, a mark is placed into the database logs at that point. So when we need to do a recovery, rather than recovering to the most recent possible point in time, which would be here and here, at which point the databases might not be consistent with one another, we are instead going to restore to that mark. We're going to do the entire restore process and stop at that mark. Now, if you need to do a marked recovery, you really don't want to use the graphical user interface, the SQL Server Management Studio. Instead, you want to come here into the books and look up recovering to a marked transaction. And essentially what you're going to use is the restore log statement. So you're going to restore your full database backup, your differential backup, and you're going to restore all of your logs. But when you restore the last log, the one that you know contains the mark, you're going to say with stop at mark and give it the mark name. And unfortunately, that's information you're going to have to get from your developers. What you may have to do is restore the entire database to a different server or a different instance so that your developers can go in and look at the data and tell you, okay, Mark A or Mark B or Mark 54 is where the data is consistent. Let's take all the database recovery files, go to the production server, and do a recovery and stop at that mark. So you may need to do a test recovery first so that your developers can go in and see where the databases are consistent. So that's how you do a marked transaction, and that's how you recover to a marked transaction. Now, another situation you need to be aware of is called orphaned users. Let's keep in mind how SQL Server works, and this scenario really comes into play for a total server or a total instance rebuild where for some reason you've lost the entire instance of SQL Server, or maybe you're just trying to rebuild the instance on another machine, and here's where you can run into that. So we've got the system and MSDB databases. So MSDB and master is what the system database is called. All of the SQL Server login accounts live in the master database. Now this database is just like any other. We need to be able to do full backups of it, we can do differential backups of it, and we can do transaction log backups of it. Then we've got our individual user databases. And these have got inside of them the database users, and that's what permissions within the database are granted to. And this of course has got full database backups, potentially has differential database backups, and probably has some transaction log backups. Now the trick is that users have to map to a corresponding login. So here's the scenario. You create a new database, you create a bunch of users, and you map them to logins. You take some backups of this database, so everything's all backed up. But you forget that you also need to back up the master database. So when you go to rebuild this server or rebuild this instance, you restore this database and you don't restore master, or you don't have a backup to restore from, and so you don't have logins. And so these users are trying to map to logins which aren't in the newly recovered master database. That's called an orphaned user. And it actually makes the database a little bit difficult to use because there's no way for anyone to connect to SQL Server and become this user. So there are some tricks for troubleshooting orphaned users. There's a stored procedure you can run, sp change users login at action equals report, and you run that from within a particular database, and that will go look for any users that do not have corresponding logins and display that information. So if you look up orphaned users in the helps online, it can also show you how to resolve this information. Go into your database, change the user's login. In other words, you're changing the login that the user maps to. And you're saying update 1, here's the user's name in the database that I want to change, and here's the new login I want to map them to. So you need to go create logins. Of course, a way to avoid all of that is to make sure that you're regularly backing up the master database. You should regularly back up the MSDB database too. That contains a lot of configuration information for SQL Server Agent. But to prevent any type of orphaned users, here's kind of my policy. Every time I back up a database, one of my databases, I run a backup of the master database too. That way I've got everything kind of consistent at one point in time, and if I ever need to rebuild the entire instance, all of my databases backups are going to match what's in the current master backup. So just something to kind of keep in mind. And probably the last caveat you need to be aware that's a little bit beyond what we have time to go into here is encryption. If you have a database that's being encrypted and you're backing it up, that restore by default is only going to be useful on the same instance that it came from. And there are definitely a lot of potential issues. For example, if you need to back up a database that contains encryption and you want to then restore it to a different instance, maybe even on a different SQL Server computer, on a different machine, then where are the encryption keys coming from that's going to allow the new machine to read that information? So that's definitely a topic that you should look up in books online to be aware of some of the issues. But I do want you to be aware that there are issues around that. And last but not least, you should always make sure you're testing your recovery plan. Just taking backups is no good if you don't know what to do with those backups. Now obviously, you're not going to try doing a restore onto your production database just to see if you can get it right. That's going to mess up your production database, probably make someone unhappy. So here's some of the options you have instead. You could restore to another database. And that would be another database within the same instance of SQL Server. Now, a downside of that is potential production impact. If you've got an instance that's really busy and it's fully loaded, putting another database on there, forcing that database to go through the recovery process and everything else, may just put a workload on the physical machine as well as the instance that you don't want to have there. So another option is to restore to another instance of SQL Server. And this can either be on the same machine if you want to, or it can of course be on another machine. And what I like to do to test my recovery plans is to go with this another machine and do it in another virtual machine. So I actually keep a virtual machine up and running, and that's the only thing I use it for, is to test recovery practices. And that kind of lets me test the worst case scenario when the entire instance goes away. In fact, here's what I'll do. I'll start with a fresh VM running SQL Server. And then I will rebuild one of my production instances. So I'll back up all of the system databases, all of the user databases, and rebuild the production instance inside the virtual machine. That way I've essentially got a virtual copy of my production server. Now another way to do this, if your virtualization technology supports it, is to use a physical to virtual or a virtual to virtual to actually copy your physical production SQL Server into a virtual machine. So at that point, I've got kind of a point-in-time copy, and I'm free to do whatever I want to do. I can make a snapshot of that so that I can always roll back to that sort of starting position. I can delete databases to simulate various failure scenarios, and then use the virtual machine to practice my recovery scenarios. I find that that's one of the best ways really for me to make sure that I know how to recover from various different failure scenarios, and definitely making sure that you have a recovery practice plan in place is just as important a part of the scenario as making backups in the first place. In this nugget, we started by talking about some of the different recovery scenarios, including a complete database recovery, file recovery, and page recovery. We talked about some of the issues here, including which ones support online recovery, which ones are supported on different editions of SQL Server, and which recovery models, full, simple, or bulk logged, are supported by each of these different recovery scenarios. We walked through a complete database recovery. We lost a little bit of data, but we got to look at some of the different options that we have for keeping as much data as possible. And we talked about some of the issues and concerns that may come up for different types of recovery and backup situations, including marked transactions, encryption, and orphaned database users. And finally, we talked about the importance of practicing your recovery plan and looked at some different options for safely practicing a recovery plan without impacting your production environment. I hope this has been informative for you, and I'd like to thank you for viewing.